Bruker has a pivotal role on driving innovation and also enhancing quality control across the whole battery value chain. From mining raw materials through cell manufacturing, operando setups until even recycling, Bruker offers comprehensive analytical solutions that focus on material properties, structural integrity, and also chemical composition. We have setups for real-time monitoring of chemical processes in fully assembled cells. All of those solutions sitting on top of a big data workflow, which allows for optimizing R&D and quality control environments and processes. I think NMR is one of the few analytics that actually offers solutions that will span over the whole battery value chain, meaning that NMR is capable of getting valuable data on the overall process that can be used to optimize material properties, to redesign experiments, or to improve cell performance. NMR is by definition a non-targeted technique, meaning we can measure any kind of substance or material. But it's also non-invasive, meaning we measure samples as they are. There's no complicated preparation process like in wet chemistry methods. On a technical perspective, NMR is a high sensitivity technique which also has high accuracy and repeatability, making one of the most common analytics in any QC environment. Bruker has made magnetic resonance technology more accessible for manufacturing environments by developing our benchtop platforms, like the Fourier 80 spectrometer or the Magnitech ESR 5000. Those two platforms were designed to be easy to use, affordable instruments capable of performing complex tasks without requiring any expertise on NMR for operation, but also delivering high quality data without relying on any special infrastructure like cryogenic liquids and so on. This actually has made magnetic resonance technology much more accessible for a broader range of users, including, of course, manufacturing environments. DLT is about method harmonization. Since we are using consistent Bruker technology across the whole chain, we can much more easily streamline audit trails, as an example, or even transfer complex methods developed in our high-field instruments to our benchtop platforms sitting in QC environments. And if you are doing this more efficiently, you are making a better use of resources as well. And of course, the key piece of this integration is actually our benchtop platform, the Fourier 80. The Fourier 80, it's an NMR spectrometer benchtop designed to be affordable and easy to use, although performing complex magnetic resonance tasks in an easy to use software.